Many of us take for granted a very extraordinary organ, our ears. To understand the ear, we need to understand what sound is. The speakers you are listening to right now are vibrating, flexing in and out, causing a wave of pressure through the air. The frequency of these waves, or the speed at which the sound-creating surface moves back and forth, affects the pitch of the sound. The level of air pressure in each wave is directly related to how loud the sound is. The outer part of our ear catches these waves. It faces forward and has a specially designed structure of curves helping us to determine direction of sound and emphasize frequencies needed for human speech. Now that the sound waves are caught, they travel through the ear canal and strike against our eardrum, a thin membrane about 10 millimeters wide. Now that we receive the sound, the middle ear transfers this energy. The smallest bones in your body, the malleus, incus, and stapes, start in motion. The malleus is attached to the eardrum, and as the sound passes along, the force is amplified by leverage until it arrives at the stapes, which acts like a piston, creating waves through the fluid of the inner ear. The most significant increase in force comes from a system of hydraulic amplification. The face of the stapes has a surface area of 3.2 square millimeters, while the eardrum has a surface of 55 square millimeters. Using this, along with a leverage through the malleus and incus, the final pressure is 22 times greater than when the sound first arrived. Now, we arrived at the most complicated part of the hearing, the cochlea. In reality, it is coiled up, but it is easy to understand straightened out. The stapes is causing pressure waves to travel through this structure. Along the inside wall is about 20 to 30,000 reed-like fibers. As the waves move along, it encounters fibers with the correct resonant frequency and energy is released. These fibers are not actually what give the signal to us that we heard something. There is a special structure containing hair cells next to these fibers. When the fibers resonate, they cause the hair cells to move, which then sends an electrical impulse to the cochlear nerve and on to the brain. Certain pitches of sound will resonate in specific locations, and louder sounds will cause more hair cells to move. Our brain interprets all this raw data, making it possible to enjoy a beautiful song or a conversation with a loved one. Just to think that all this is happening in your head right now at full speed. And not just one, but two of these sophisticated instruments are helping you to have the amazing sense of hearing. This is just one of the many systems found in the human body that go far beyond our humble human understanding.